Okay, okay, so for our next page, we're going to start with b, y equals the tangent of 1/3 x minus pi over 2. So to find the period, I'm going to do pi over k. My k value is 1/3, so it's like pi divided by 1/3, which is pi multiplied by the reciprocal of 1/3, which is 3. So 3 pi is going to be my period for this. All right, and then the next thing we're going to talk about are what are the transformations of this graph. So if you look at the tangent of 1/3 multiplied by the quantity x minus pi over 2, hopefully we notice there is a phase shift. Okay, so you have a phase shift of pi over 2 to the right. Okay, which means your b value is going to be pi over 2. You also are going to have a horizontal stretch by a factor of 3. Okay, so that comes from the 1/3 inside here. So if you have the 1/3, remember with horizontal stretches, it's the reciprocal. So this is going to be a horizontal stretch by a factor of 3. Okay, so what's happening there is the graph is going to get wider because if it's stretching it horizontally, it's pulling it horizontally. Okay, and then so you can do this a couple different ways. You can either plug in values and plot those points. You will get some decimals depending on what you plug in. If you do, you can keep going until you get something that is not, but really you want to find what your key points are. So for this one, our phase shift is pi over 2. So a smart thing to go by on our graph would be pi over 2. Okay, and I think I went every other one on this. Okay, so if you go by pi over 2, I'm going to start here. So this would be 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then I'm at 2 pi. And it's okay that it doesn't go all the way out to 3 pi, because remember, to get to 3 pi, I can go from 2 pi to negative pi, and it is still the same length, and that is perfectly fine. Okay, so negative pi. And then this will be negative 3 pi over 2. And then this will be negative 2 pi. Okay, so you can think of this as normally when you're graphing your parent function without your phase shift, think about where your tangent starts. So if we go back to our original graph of our tangent right here, sorry, that's your cotangent. Your tangent, it's going to be right at 0. Okay, now because I have a phase shift of pi over 2 to the right, if I usually start at 0, what's going to happen is this is just going to be moved pi over 2 to the right. So I am directly here. Okay, I'm directly here at pi over 2 on the x-axis. Okay, so I'm going to put that down on my table. So if we're making the graph of a table for the parent function, the parent function is just going to be your equation without your phase shift. So if we plugged in 0 into this equation, the tangent at 0, think about where 0 is. Okay, and at 0, it's going to be 1, 0. So 0 divided by 1, which is 0. And then all we did here is we did a phase shift of pi over 2. So my x point is going to be pi over 2, 0 for my new graph. Okay, so for the graph of y equals the tangent of 1/3 x minus pi over 2, okay, then you know it's pi over 2, 0. Now you could have also gotten that by plugging in pi over 2 into this graph, so that's fine too. It's just sometimes it's easier with your other graphs. Okay, so at pi over 2, if you plug that in, you can find out what your value is for y. And I'm going to show you a couple different ways to do this. So if you just plugged in like pi over 2 into your parent function here, you'd have the tangent of 1/3 times pi over 2, which is the tangent of pi over 6. And then the tangent at pi over 6 is going to be the square root of 3 over 3. And then once you know that, that's for plugging in pi over 2, you can just shift that over to pi. Okay, so you can convert that into a decimal. It's going to be approximately 0.57. So if you wanted to graph pi and then 0.57 on your graph, you could absolutely do that. Another way you can think of this is, where is the asymptote going to be? So on the original graph, remember that our asymptote was at pi over 2. If on the original graph it was at pi over 2, because this has a horizontal stretch by a factor of 3, if you multiply that by 3, it would occur at 3 pi over 2. But remember, this also has a phase shift. So instead of it occurring at 3 pi over 2, we're going to have to shift pi over 2 to the right. So if we do that, we would add 3 pi over 2 plus pi over 2, which is 4 pi over 2, which would be at 2 pi, which means that's where our asymptote is going to be, okay, at 2 pi. All right, so that's what I'm putting in there, is my asymptote. And then remember that you are going to have another asymptote, and the asymptote for this is not going to be pi away. It was pi away before because that was the period, but what is our period here? The period is 3 pi. So I can count back 3 pi, and that's where my next one is. So if I'm at 2 pi, this would be 1 pi unit, this would be another pi unit, this would be my next pi unit. So that distance would be 3 pi. So this would be where one of my other asymptotes is. So it would be at negative pi and 2 pi. And we know the distance between that is 3 pi, because if you did 2 minus negative pi, it would be plus pi, and you would get 3 pi. Now really what we're going to do in here is curve these so that they follow the asymptotes. I'm not going to be super picky about where your values are. Like I told you before, we found that at pi it's at 0.57. So if this is 1, 2, 3, 4, if you guys wanted that in there as a guide, that's perfectly fine. It'd be a little more than halfway. That's okay. Okay, and then you could also go back the other way. So if this is 1, 2, this will be 1, 2. Sorry, not for you. All right, and then that would be one period of the graph. Now you also have to keep in mind, this is going to keep repeating itself, so you are going to have part of the graph up here. So if this occurs at every 3 pi units, okay, 3 pi units is going to be 1, 2, 3, 4, 5, 6. So 6 units from here. So 1, 2, 3, 4, 5, 6. It's going to be right here is where the center is. So all you're going to see from that is this part of the graph.
This is a reminder for those of you.
Okay, and you do need to span your entire graph. So yes, you have to put this part in here too. Okay, and then again, if you wanted to, you're welcome to plug in your points either into your parent function or into the original function. And then if we want to check this with our graphing calculator, we can do that. So I would do the tangent of 1/3. So I'm going to have to put this, the 1/3, in parentheses first. And then it's 1/3 times x Okay, and then that will be times your x minus, and then pi over 2 is going to go in parentheses as well. So you're going to close those. You're going to close the second one. You're going to close the third one. For a window, if you want, you can go exactly to what we did. You could go negative 2 pi to 2 pi is fine. Your scale pi over 2. And then you can check out your graph and see how they match up. All right. Good job. All right. I'm going to do part C in a different video. Thanks.